Welcome to this explainer. Today, we're going to completely rethink that fish that eventually ends up on your dinner plate. For decades, the aquaculture industry has been laser focused on basically one primary goal, and that's maximizing production volume to feed our rapidly growing planet. But right now, there's this incredible paradigm shift rippling through global aquaculture. We're actually moving away from the bare minimum of merely keeping fish alive, and we're stepping into a completely new era where the industry is actively trying to give them a life truly worth living. It's fascinating stuff, so let's just dive right in.
So, let me ask you something. Can a fish actually be happy? I know it sounds a bit out there. For a really long time, the commercial industry basically treated fish as unfailing commodities. Just simple organisms operating purely on reflex. But recent scientific breakthroughs have completely shattered that old preconceived notion. We now have concrete, undeniable evidence of fish sentience and emotion. And the things we're learning? Well, they aren't just fascinating from a biological standpoint. They're actually forcing a massive ethical and commercial mandate across the entire global seafood supply chain.
Here's our roadmap for the explainer today. 1. The awakening of aquaculture. 2. Toward positive welfare. 3. The value of welfare. 4. Measurement tools. And finally, 5. Commercial barriers.
All right, let's jump right into Section 1, the awakening of aquaculture and rethinking fish sentience.
Look, we've got to start by busting a deeply ingrained myth right out of the gate. That's the idea that fish just possess these simple, reflex-only nervous systems and literally don't feel a thing when they're handled or harvested. The scientific definition of aquatic sentience proves that is simply not true. Recent research actually shows that fish possess a peripheral nociceptive system. Basically, that's the system that detects cellular damage, and it is strikingly similar to the one we have as mammals. Plus, fish have sophisticated brain structures that are homologous to the cerebral cortex and amygdala in mammals, meaning they don't just reflexively twitch away from harmful stimuli, they actively, consciously process pain and fear. And honestly, it's not even just fish. There's really strong evidence that decapod crustaceans, think shrimp and prawns, also experience nociception and conscious pain. So acknowledging this sentience, it transforms animal welfare from some fringe, nice-to-have idea into an absolute ethical mandate.
Moving right along to Section 2, toward positive welfare, moving beyond basic survival.
This right here is where we see the fundamental conceptual shift I was talking about. It is no longer enough to just keep the fish breathing. The new goal is to actively make them thrive. Or moving away from what you'd call traditional welfare. That was a reactive model, mostly based on the old 5 freedoms, which just ensured animals were free from things like hunger, pain, and distress. Just maintaining homeostasis, basically. But this new paradigm, positive welfare, this is completely proactive. It's built on the allostasis model, where welfare is achieved by giving fish agency, helping them build up resilience, and genuinely allowing them to experience positive mental states. It's all about giving them manageable challenges, something called eustress or good stress, that actually stimulates their motivation and creates truly rewarding experiences for them.
So what does this actually look like down in the water? Well, modern farms promote this positive state through very practical, tangible applications. A huge one is environmental enrichment. Instead of just dumping fish into a sterile, empty tank, farms might introduce benthic substrates like sand or gravel to the bottom, allowing species like tilapia to actually build and defend their natural reproductive nests. Or they might use dynamic bubble curtains that the fish can voluntarily choose to swim through and interact with. By giving them these behavioral choices, like deciding whether to swim against a current or just rest, farms are granting these animals a real degree of control over their environment. And that drastically improves their cognitive flexibility and their natural stress response.
Okay, Section 3, the value of welfare. Basically, the business of happy fish.
Here is the incredible thing. Ethics and economics are completely aligned here. Fish that are raised in optimal, enriched, low-stress environments, they develop much stronger immune systems. For a farmer, that means a massive drop in mortality rates and way less reliance on antibiotics. They also show a much faster feed conversion ratio. They literally turn their food into body mass more efficiently, which saves farms a ton of money on feed. But it also directly impacts the actual seafood you buy at the grocery store. Happy, healthy fish yield a firmer flesh texture, they prevent rapid postmortem pH drops, and they literally have an extended retail shelf life. A win all around, really.
And this biology is exactly why humane slaughter is just non-negotiable at this point. If a fish experiences acute stress right before or during harvest, say through outdated, inhumane methods like live chilling in ice, which sadly is still out there, their body just panics. This panic prematurely depletes all their ATP energy reserves and causes lactic acid to flood the system, which completely crashes the muscle's pH. And that irreversible crash destroys the physical properties of the flesh. It ruins its water-holding capacity and makes the texture super flaccid and mushy. So using compassionate, instantaneous stunning isn't just about preventing agony for the animal, it literally protects the commercial value of the fillet.
Which brings us to Section 4, Measurement Tools. How farms measure the unseen.
Now, you might be wondering, how can a farm operator actually know if a massive school of thousands of fish is experiencing positive welfare? To do this, the industry uses a really clever step-by-step tiered assessment approach. The goal here is to optimize resources and avoid causing any unnecessary handling stress to the school. Step 1 is Tier 1, just a primary visual assessment of the school from a distance. They're looking at group swimming behavior, appetite, basic water quality. Now, if anomalies pop up there, they move to Step 2, Tier 2. This is a secondary individual examination where operators gently and quickly check a few specific fish for physical damage. And only if the problem persists do they escalate to Step 3, Tier 3, which is advanced lab analysis, like testing blood metabolites or performing histopathology.
When operators do have to perform those Tier 2 physical checks, they don't just guess. They use standardized tools like a clinical scoring matrix for operational welfare indicators. Field operators use these specific grids to mathematically score any physical damage. For instance, if they're looking at fin erosion, they grade it on a scale from P0, meaning perfect intact fins, all the way down to P3, which indicates severe erosion and necrosis. Same with eye cataracts, grading from P0 up to P4, based on how opaque the lens is. This matrix is incredibly crucial because it totally removes human subjectivity and bias from the auditing process. It gives farms hard, scientifically precise data to work with.
But honestly, the future of welfare monitoring is completely hands-off. We are stepping into the era of precision aquaculture, and it's amazing. Technologies like non-invasive artificial intelligence, computer vision systems, and biologgers are absolutely revolutionizing the space. Just imagine AI cameras continuously tracking a school's swimming patterns, mapping sea lice infestations, and even measuring a single fish's ventilation rate just by watching its gills move, all without a human ever laying a finger on the fish. Or consider microbiosensors, acting as little sentinel fish, swimming within the school, beaming real-time heart rate and stress data straight to an operator's dashboard. It is a total game changer for continuous, stress-free monitoring.
Finally, let's get into Section 5, Commercial Barriers. It's time for a quick reality check.
Over 300. The global aquaculture industry currently farms over 300 entirely different aquatic species. And the stark, uncomfortable reality is that we have a massive lack of baseline behavioral data for the vast majority of them. And that lack of data? It's a huge problem. Take swimming speed, for example. Fast swimming might indicate that an Atlantic cod or a gillhead sea bream is stressed out and underfed. But for an Atlantic halibut, that exact same fast swimming represents a natural, healthy foraging motivation. It perfectly highlights this massive species-specific data limitation. What makes one species completely happy and motivated can be a glaring sign of distress and panic in another. You simply can't write one universal welfare manual and apply it to every farm. Everything has to be rigorously tailored to the exact species and its specific life stage.
Beyond just the knowledge gap, we're looking at some highly practical roadblocks to implementing positive welfare. Creating these complex enriched environments requires a really high initial investment, and it makes routine tank cleaning significantly harder. There are also very real biosecurity risks. Adding physical structures like substrates or hides can ironically trap organic waste, harbor dangerous pathogens, and lead to biofouling. Plus, if environmental enrichment isn't managed absolutely perfectly, it can actually backfire and spark increased aggression. You'll see dominant fish fighting and injuring subordinates just to claim those new artificial shelters. Ultimately, there is a very wide gap between what works perfectly in a pristine, controlled laboratory and what is actually viable in a massive, real-world industrial operation.
Which brings us to our final thought today. Can the future of the global seafood industry truly balance the demands of massive commercial scale with providing a life truly worth living for the fish? As we've seen throughout this explainer, pushing for positive welfare isn't just about minimizing animal pain anymore, it's genuinely about optimizing health, product quality, and the sustainability of the whole ecosystem. The amazing monitoring tools are being built, the science is crystal clear, but overcoming these commercial and data hurdles, that's what's going to define the next decade of our food systems. I really hope this explainer has completely changed how you view modern aquaculture. Keep asking those hard questions, keep looking for those high welfare certifications at the store, and never stop learning.